Hello there guys, and today let's talk about compression. More importantly, let's talk about why compression is used. Okay, so what is compression? Compression is used to encode information in a way to take up less space, space being measured in computer memory in this particular case. Decompression is the reverse process, reading the information that was compressed and reconstructing the original. And to give you an example of a compression, let's say that I had 5 letters A in a row. Okay, so I had A. Okay, and let's say that each one of those letters is 1 unit of memory. Okay, so each one of those letters is 1 unit of memory. Okay, so if I was actually sending this information, or if I was actually trying to store this information or whatever, I would have to spend 5 units of memory. Okay, so this right here would actually bring me 5 units of memory, and I'm going to abbreviate this as units of memory. Okay, so this is 5 units of memory. However, if, for example, I agree either with myself, if I'm storing these files myself, or with somebody else, that if I'm sending the file to somebody else, that, for example, if I write A5, that actually means that I am actually writing A, then what is actually happening is if both people, if I'm sending it to somebody else, or if I somewhere on a piece of paper write a rule, okay, A5 means A repeated 5 times, then what actually that means is that right now I saved up 3 units of memory, because if each character is 1 unit of memory, this is 2 units of memory. Okay, so this is significantly cheaper to store than this right here. Okay, and how much cheaper is it to store? Well, the compression ratio would be 5 divided by 2, because this is the uncompressed size, and this is the compressed size. Okay, but this shouldn't really concern you. This is just something that I mean, I included this in my written copy, but I'm not sure why I said it now, because it's not really that relevant. But anyway, basically compression is used to compress information, to say the same information, but in less space. Okay, we need less space to express that same information. Okay, and I just wanted to also note that data compression can be lossless or lossy. Lossless means that no information is lost, and in our example we are dealing with lossless because no information is lost. And lossy compression means that we lose some information in the compression procedure, but we can gain a close approximation when decompressing it. Okay, and those are just some basics idea. Those are some very basic ideas about compression and decompression. I just think that if you look at the field of information theory, you are going to find a lot more information if you're interested in this. But yeah, those are some basic things which is actually happening in compression and decompression. Again, the algorithms themselves are much more complicated probably than this one. I mean, certainly they're much more complicated than this little algorithm, but basically the gist of it is that we are trying to compress a lot of some information into a smaller amount of information. Now, if we do it without a loss, it's called lossless. If we do it with a loss, then it's called lossy. Okay, so this is pretty much it for this tutorial. I hope you followed along, and I hope to see you in the next tutorial. Talk soon.